Morning. Today's class is on endometrics. Endometrics is a terminology used for describing root canal working length determination. So this is very important topic, very important. So because your endodontic treatment, the results of your endodontic treatment depends on the determination of the working length. When you do endodontic treatment, accurate or correct determination of the working length will give you the best results in your canal preparation and shaping and observation. So the results outcome of your treatment is always more accurate when you do a correct working length determination. Now, coming to the definitions. So this is the definition given in the endodontic glossary. Working length is the distance from a coronal reference point to a point at which canal preparation and obturation should terminate. Now, the distance from the coronal reference point. When you determine working length, there should always be a coronal reference point. This is the point at which you start measuring the canal length. So, coronal reference point in an incisor tooth, it's always the incisal edge. It is a flat surface which is constant. You should be able to repeat because each visit the patient comes to your clinic. You should be able to repeat the working length. The coronal reference point should be taken as a repeatable point from which you measure the working length. This point should be a constant point. It shouldn't be a weak enamel. It should be a firm tooth structure. In an anterior tooth, I told you, it is incisal edge. In the posterior tooth, it's usually the cusp tip. In a fractured tooth, the coronal reference point should be flattened to make a flat surface, and the apical point is the point or the minor diameter of the apical foramen. This is the point which you have to determine and measure. So the distance from the coronal reference point to the apical point is the working length of the tooth, and it is this length which the clinician should work or clean and shape the canal to irrigate, or your irrigant materials shouldn't go beyond this working length. It should be confined into the canal space only. Even your obturating materials shouldn't go beyond this working length. This length is the space which you have to work during endodontic treatment. And there are a few terminologies which you should be knowing. They are the anatomical effects and radiographic effects. Anatomical effects is the tip or end of the root canal determined morphologically. So, the morphological end of the root is called the anatomical effects, and the radiographic effects is on a radiograph where you see the end of the root, that is called the radiographic effects. It is the tip or end of the root determined radiographically. Now, both these points needn't be same. If the tooth root is slightly curved, when you see the anatomical effects is actually longer than the radiographic effects. So on a radiograph, this curved portion, the tip may not be say recorded on a radiograph. So what you see on the radiograph is not what is the actual anatomical effects. Now coming to the apical foramen, you have the main apical opening of the root canal. It is frequently eccentrical, located away from the anatomical or radiographic effects. And apical foramen is the point where the canal opens into the periodontal space. So, and it is through this point the blood vessels, nerves enter and exit out of the pulp. So, the apical foramen is very important area of landmarks which should be determined. Now, in the they are the minor apical diameter and the major apical diameter. Now, in this, the minor apical diameter is the apical portion of the root canal having the narrowest diameter. It is usually 0.5 to 1 millimeter short of the center of the apical foramen. So, the minor apical diameter is the reference point at which you measure the working length, and it is this point only till this point you are supposed to prepare or clean or shape the canal. Whatever medicaments you place in the canal should be left only up to this point. You shouldn't go beyond this point. Violating the apical diameter can hinder your prognosis. So this minor apical diameter is a very important point in working determination. And usually after this minor apical foramen, the canal widens apically to the foramen. That is a major diameter and assumes a funnel shape. Now in this diagram, you can see the root apex, the canal narrowing into the narrowest point, point A, which is called the minor apical diameter. And after the point A, the canal flares out. It has a funnel-like appearance, and it flares out, and the outermost diameter is larger than the minor diameter. So the outer diameter is the major apical foramen, and the minor B, that is point B, and point A is the minor apical diameter. Now, the objectives of canal cleaning and shaping is to you should not instrument beyond the minor apical diameter. Do not increase the diameter of the minor apical foramen. Only then you will be able to confine your oscillating material within the pulse space. Then you have another terminology called the cementodentinal junction, the region where the dentin and cementum unites. Usually, cementodentinal junction does not always coincide with the apical construction. So, the minor apical diameter is a clinical, it's a anatomical point, and cementoenamel junction is a histological point. So, both these are not the correct; they do not coincide. The location of CDJ ranges 0.5 to 3 millimeters short of the anatomical apex. So usually in a tooth, it is around 0.5 to 3 millimeters away from the anatomical apex. Now coming to reference point, I told you, is that site on the occlusal or incisal surface from which you start taking your measurement. So the reference point is usually the coronal reference point. It should be stable and easily visualized. So once you decide on a reference point, you should select the reference point which is stable. That is, sometimes the patient comes the next visit, that reference point should be there firm, so that when you take the measurement next time, the recorded working length is the same. If this reference point breaks away or it chips off, it's a weak enamel. Next time when you take the working length, the reference point, if it is changed, your working length is also changed. So you may have to retake the working length once again. And it should be easily visualized. So that is, on a radiograph, when you take this reference point should be reproducible. Then you should be able to visualize the reference point each time you take the working length. Should not change between appointments. Yeah, like if it changes, your working length measurements also change, and your treatment results will go wrong. So once you select the reference point, it should be stable, easily visualized. It shouldn't change between appointments. And usually the highest point on the incisal edge of buccal cusp or posterior. In incisal edge, it is the highest point on the incisal edge, and the buccal cusp of posterior teeth. Now, do not use weak enamel walls or diagonal lines of fracture as a reference site for length of tooth measurement. That is, if a tooth is fractured diagonally, you shouldn't take a diagonal point Yeah, you shouldn't. Yeah, you shouldn't take. So do not use weakened enamel wall or diagonal lines of fracture as a reference site for length of tooth measurement. That is, in this diagram you can see the diagram A. There is a diagonal fracture. A slope cannot be taken as a reference point because this second time when you're trying, the slope will not be reproducible. Each time it wouldn't be the same point. So if you have a diagonal fracture tooth, you must flatten one end. That is one end, make it flat so that when you place the stopper on the instrument, that point is reproducible. Each time you take, it is taken from the same point. Now, weakened cusp or incisal edge are reduced to a well-supported tooth structure. Diagonal surface should not be flattened to give a accurate site of it. Okay. Now, now taking all that apart, working and determination, you have two basic methods of working and determination. One is the radiographic method and other is the non-radiographic method. Now, in radiographic method, you use X-ray or radiographs to determine the working length, and in that you have the Grossman's formula, Rain's method of taking working length, English method of taking working length, and according to Cutler studies, Cutler method, wire grid method, endometric probe method. All these are the different methods of taking working length with radiograph. Now, without radiograph, there are some few methods using digital tactile sense, then apical periodontal sensitivity, then paper point evaluation, and electronic methods. They are the electronic effects methods. So these are the different methods of taking work length without radiograph. Now, first coming to the digital tactile sense. As an instrument is passed into the clinician feels increased resistance at the apical 2 to 3 millimeters. So when you pass the instrument, the number 15 size instrument through the axis opening, through the coronal axis into the canal, as the canal tapers to the apical foramen, when you reach near the apical foramen, you feel that the instrument is retaining resistance. So that is one method of determining the apical construction. But this is not a very accurate method because it depends on the diameter of your instrument which you're going to place inside, the diameter of your apical foramen. So it's not a very accurate method. And in mature apex of calcified canal or narrow canals, these readings may change. So in mature apex, it's a wide open apex. So you will not be able to feel any resistance. But in a calcified canal, when there is calcification from the coronal start itself, you start feeling resistance. Same way, if there is a very narrow apical constriction, you start feeling resistance too early. All these are not a very accurate method. Now, determination of working length by digital tactile sense, it is the earliest method. Although it may appear to be very simple, its accuracy depends on sufficient experience. So this is not, as I told you earlier, it is not a very accurate method. It depends on the clinician's expertise, and still, even still, it doesn't give you a very accurate result. The clinician should be able to literally feel the apical foramen by tactile senses. And confirmation may be done either by radiographic or electronic method. So this can be used as a subsidiary method. So once you determine the working length in this method, you can reconfirm it using the electronic effects method. If the coronal portion of the canal is not, the coronal is not constructed, and experienced clinician may detect it with the increased resistance as you approach the 2 to 3. Now, the next method of determining the working length is the working length by apical periodontal sensitivity. This is a method of working and determination based on the patient's response to pain. So, does not mean the ideal method of working it. It's not a very accurate method. That is, once you extirpate the pulp and then you place the instrument into the canal, not under anesthesia, without anesthesia, when you place the instrument into the canal, when the instrument reaches the apex foramen, the patient will start having sensitivity. That shows the nerve endings at the apex are being stimulated. So this is a method to determine the RSA. It's not very accurate method because when you extrude the pulp, it's not necessary that the pulp is severe corrected the apex foramen. It can be severe more into the canal. You may get an early sensitivity response when you place the instrument into the canal. So it's not a correct or accurate method. Then determination of working length by paper point method. This is also not very accurate method. In a root canal with an immature wide open apex, the most reliable means of determining working length is to pass a blunt end of paper point into the canal after procuring the anesthesia. So when you place the paper point into the canal, and when you remove it out, you see blood tint at the end of the receipt. So from the coronal reference to the area where the blood tint is measured. The moisture of blood on the portion of the paper point that passes beyond the apex and estimation of working it or junction between the root apex and the bone is measured. This method, however, may give you unreliable data. If the pulp not completely removed, if the tooth pulpless, but perioperative lesion within blood supply is present. If paper point left in the canal for too long, all these can give you different, not accurate. Now coming to determination of working length by radiographic method. Determination of working length by paper point method. Next is the Grossman's method of working length determination. It is also called the formula method, given by the formula for determining the correct working length rule of proportion basis. CLT, where CLT is the correct length of the tooth. KLI is known length of the instrument in the tooth. ALT is the apparent length of the tooth on radiograph, and ALI is the apparent length of the instrument on radiograph. So, correct length of the tooth is equal to the known length of the instrument in the tooth multiplied by the apparent length of the tooth on radiograph divided by the apparent length of the instrument of the tooth. By using this formula, you can calculate the length of the canal. This was a formula method used earlier, but it gives you somewhat near close to the accurate results. But now you have better working and determination method.